Okay. Hello, this is Mr. Harris. I'm going over your quiz 1. I'm going over the quiz where you have to write the hypothesis test, and then I'm going to go over alpha, beta, and power. The next video, I'll be going over the 2 answers to the free response quizzes. And also have a video coming out going over your Unit 8 test. Those grades are already in Power School if you turned in your test. Generally speaking, these are the answers. IGIH. Okay. Again, tutoring is most days from 3 to 4. Thursday, there's faculty meetings. So tutoring will be Thursdays, 3:30 to 4. And for some reason, they like having random pop-up meetings on Tuesday. So if I have to be at some meeting Tuesday, around that time, I'll just let you know. Don't wait until the last minute because that day I may not be doing tutoring. So if you can be at tutoring, show up, be proactive. These are the answers. Hit and miss. Some people got a lot right, some people didn't. I'm going to discuss number 4, but okay. So looking at number 4, power is 1 minus beta. Beta you can view as sort of the antithesis of alpha. Alpha is the inherent error that we are willing to work with. So and beta and alpha play off each other initially. Beta is also influenced by sample size. Alpha is not influenced by sample size. Alpha is influenced by industry standards, what error you're willing to live with. So in this case, if my alpha is 10%, therefore my beta is 90. Therefore my beta is 90. I actually need to change that. I'm wilding out. 90%, so that should be 0.10%, 0.95, 0.05%. Okay. In this case, my alpha is 5 and my beta is 95. So which of the following would result in a more powerful test in this setting? An alpha of 10 leaves us with a beta of 90. 1 minus 0.99% leaves us with 10%. Therefore, an alpha of 10 would have a higher power, a more powerful test than an alpha of 5%. That's it. That's why it's H or C, whichever version you had. Okay, let's look at a few graphics discussing beta in more detail. Okay, so initially, again, the probability of a type 1 error is alpha. The probability of a type 2 error is beta. Very few of you watch those videos regarding this. If you don't know what this is, I suggest you watch those videos. Power is 1 minus beta, so 1 minus the probability of a type 2 error. Share screen. Let's look at another situation. Okay, here we go. Again, the relationship of alpha and beta. We're viewing this in terms of 2 overlapping theoretical normal distributions. There's a probability of the null hypothesis, the probability of your alternative hypothesis, and there's always an overlap. There's a world where your null and alternative can both exist at the same time. It's just generally, if you're sampling, what's the likelihood? Are we going to land more here, or are we going to land more here? Let's look at another image. Okay. More relationship between alpha. Alpha is static, whatever we choose. 1 minus beta, 1 minus alpha. This is all that rejection region stuff. Let's choose another image, shall we? Okay, and this is a very helpful image comparing the relationship between alpha and beta in power. Remember, power is 1 minus beta. This would be our alpha, but notice our alpha is held static, whether it's 1%, 5%, 10%. Let's see what happens as we increase our sample size. So right now the sample size is 9. Look at the shape of the graph and how beta changes. So there's some ways to increase power. One way to increase power is by increasing alpha. However, if you increase alpha, you increase your risk of a type 1 error. So there's a give and take. To increase power by increasing alpha, you're increasing the inherent error. Another way to increase power while having a low alpha is to increase your sample size. So that's the best way. Notice our power is increasing. Our power increases as our risk of a type 2 error and beta decreases, yet alpha is held static. Also notice the graphs are becoming, the standard deviations decreasing, and the lower your standard deviation, the better. The higher standard deviation, theoretically, the worse. Remember, in the generic theoretical normal curve, standard deviation is 1. In this case, standard deviation gets down to only 2, but that's still really good. And then you can see that there's a more inherent marked difference between your null and alternative hypotheses, because we want to be able to tell, is there an obvious difference or is there a problem? So there, you're actually driving a wedge between them to be more precise. And that leads us to our last graphic. Okay, this would be a two-tailed hypothesis test. Please remember, a two-tailed hypothesis test is just like a confidence interval. Confidence intervals give you the same information and they give you a bit more. Not only do they allow you to say, do we have evidence to reject the null hypothesis and accept the alternative, they also give you a benchmark between plausible values on top of that. When I go over the quizzes, I'm going to show you how to calculate p-values by hand. Your calculator does pretty much handle that for you. However, if you're in a bind and your calculator is acting funny, if you're calculating p-values by hand and it's two-tailed, you do have to multiply the p-value times 2 or add up both sides. Read this, view this, let me know if you have questions. That's it for quiz 1. Let me now go through your hypothesis test. This is an example of, so let's read through this. This is an example of one test that was sent me. The electric car vehicles are the same as the gas engines, or generally hypothesis tests, you're setting up your experiment. You need to decide, do I have a one-tailed test or a two-tailed test? There's no need for the or. I wasn't testing, were you listening to the Mythbusters? I want you practicing writing good hypothesis tests. So the electric vehicles are the same speed as the gas vehicles, period. That's a reasonable null hypothesis. The alternative, the electric vehicles are not the same speed as gas vehicles. obvious two-tailed tests. Because if it's not the same speed, it could be quicker or slower. If you're going to go, the electric vehicles are faster than the gas, your alternative is electric vehicles are not faster than the gas vehicles. And it has to be based off of that, and you're only collecting evidence relative to electric vehicles being faster there. The amount of methane gas cows produce is not significant towards climate change. Methane gas cows produce is significant. This is very good. Especially the assumption is that if you don't know, say there is no significance, and then the alternative saying it is producing. This is a two-tailed test. The way the batteries speed up, the way the batteries slow down. This is okay. That would be a one-tailed test. Even though I'm struggling visioning this in my head, the way the batteries slow down, so we want to see that the speed is going to be less, but here we see the batteries speed up. I have an issue comparing this with that because drawing a graph and coming up with a mathematical conclusion would be cumbersome. I would say the weight of the batteries has no bearing relative to the go-kart as compared to gas, nothing. Then you say the weight of the batteries slow down. So you know it's an obvious left-tailed, one-tailed test. So be very careful where you can draw a picture from your null and alternative hypotheses. Let's look at one more. Okay, so this one, electric cars have no difference in maximum speed. Electric cars have significantly different maximum speeds. That's good. Two-tailed tests. I wouldn't use significantly here because we save that for special instances, but that's legal speak. Cars are not significantly. Again, we don't need all that significant. Just say it's different. Because even if you setting up, we want it to be significant, but if it's not, doesn't mean we don't have plausible information. Too much focus on the word significant. There's no difference in maximum speed between electric and gas. There is a difference between the maximum speeds, two-tailed tests. The increase in greenhouse gases is not contributing. The increase in greenhouse gases is contributing. Is not, these are two-tailed tests as well. Is it? Contributing to the melting. So it's more melting. It's not contributing to the melting. So it's going to be a status quo of melting based off of room temperature with nothing versus more melting. So on second thought, this is actually a right-tailed, one-tailed test. The importance of being able to draw and decide is it one-tailed or two-tailed from these hypotheses. You shouldn't have to read it so many times to figure it out. It should be a bit more clearly and obvious. For those that read through the slides, also regarding your research, your future research, whether it be your capstone or college or your career, I hope you paid attention to the operational definitions. They're there mostly for your own benefit. If you had a paper, this is where your lit review comes from, you would have to operationally define greenhouse gases in your lit review or maybe somewhere in an appendix. But what specific greenhouse gases? If you're testing for all of them, that's sometimes too much. Narrow it down to one greenhouse gas or two. But oftentimes in the lab, mixing two together creates problematic situations. So maybe just stick to the one. Electric, gas, go-kart, atmosphere. Atmosphere is general enough that atmosphere is very general. Speeds were okay, obviously defined kilometers per mile or miles per hour. The biggest thing I see here you have to operationally define is greenhouse gases. Maximum speeds, you would have to decide a straight track or a curved track. You would have to, if it's curved, you have to discuss the suspension and tires because that has a lot to do with the driving capabilities. Let's look at the last one. Well, just the last one I chose, one more. Okay. Um, the use of electricity instead of gas does not affect. Good. Cars that run on electricity run faster than cars that run on gas. That's good. Obvious, run faster. It's a right tail test. Presence of carbon dioxide will not affect, will slow down. Good job. And notice here, it was much more straight obvious, left tail, one tail test, because it's not affecting the rate the ice melts. This is a very good clear cut definition. You want your null and alternatives to be clear and precise. Um, you obviously have to define how the ice is melting. Often, also notice carbon dioxide versus general greenhouse gases. You want to be specific in your research as possible. The more specific you are, the easier it is to weed out lurking variables. The presence of cows will decrease the amount of methane gas, will not affect the amount of methane gas. Will decrease. Generally, um, yeah, for a null, it's the status quo. You're not going to be changing anything for your null. That's what things are. It is what it is for the null. The presence of cows does not do anything. I would switch this. This is an alternative. I mean, this is a null. The null is the cows will not affect the amount. The alternative would be the presence of cows. So I would switch and flip these. The null is what is, and then the alternative negates, whether it's more, less, or different, generally speaking. Um, good job, the counterparts. Um, okay. You have to define the kinds of batteries used, see which batteries work best, but that's it for these two quizzes. Look for a video going over your tests, and then look for a video with the solutions to the two quizzes. Thank you, and have a good day.